Welcome, I'm Bill Wake. We're here working on an interpreter for a programming language called 10th that's sort of like 4th, and lately we've been working on the dictionary, so we're going to pick up there. The dictionary is where all the system words are going to be defined, and then where the user words will be defined. Okay, so when we left off, I just reran the tests, and everything is good except for the ones around the dictionary. So this search word not found returns 0. We're getting a segmentation fault in there. And let's see. So that's the last one we had. Let's go to that test. Okay, so we add in a couple of dictionary entries, and then we look for NL and call dict search, and we expect 0, but we're not getting that. Well, we're getting a crash, basically. All right, and then I noticed this line while I was preparing my weekly summary. X0 is still the address of the input string. Well, that's not true. It's true if you came in the first time, but once you've called another function like string EQ, it's not guaranteed that X0 will be different. In fact, string EQ modifies X0, so it's not going to be the same. It returns 0 or 1. So yeah, that's not going to work. All right, let's walk through this again, just kind of refreshing our memory. So dictionary search, address of 10, X0 is the address to look for. That's the input argument. X10 is the temp we're using while we walk through the dictionary. So it's a singly linked list. The X21, X21 is the pointer to the front of the dictionary, or the most recent addition, and we're going to traverse it using X10, walking its way down through that linked list until we get to the bottom. All right, and so what's happening is we need to keep track of the string we're looking for, because that has to be searched for every one of these. So we were using that in X0. We just have to put it somewhere else as well. And one of the things we have is I think we can push it on the stack, I guess. So if I store X0, that's our input, at SP pound minus 16 bang, that says push X0 on the stack. Now we have to alternate because the stack has to be aligned to 16 byte boundaries. And if we have two things to push, that works out. But now we have another one. So even though we only want to push one that's 8 bytes, we still reserve 16 bytes of space. One of those quirks. Okay. All right. If we need to save anything else along the way, then that's fine. But what this gives us is we can pull that stack entry out anytime. Okay. And this is string, address of string to look for. Search string. Close enough. All right. So this is fine. We got to move X10 down. Let me get those registers. Golly. I'll memorize this someday, and then I'll never do ARMA again, probably. So my registers, some of them are temp, some of them are caller owned, some of them are callee owned, and I want to get them right. Calling standard. Okay, so X0 through 7 are your arguments, and nobody will save those. X9 through 15 are temp registers, which are caller saved. Now, maybe it would make more sense to put that X0 in there. Let's see if that makes better sense. Well, we'll store it. Then I would be saying, let's try it that way. So let's move well, no, you know what's going to happen? Okay. I still got to store, but I'm going to work with X11. And then I'll have to restore it quite so much. All right, so X11 it's a callee must save. So if somebody's going to call you, like the calling routine has X11, it owns X11. We can use it, but we have to save it before we use it. X0 through X7, if the caller puts stuff in them and it wants it when it gets back, that's the situation we're in. It has to store it somewhere because the called routine is allowed to mutilate X0 through X7 however it wants. All right, so by pushing X11 on the stack, and then so that's no longer that. It's more just a normal stack thing. Okay, and then at the end we got to bring X11 back, and it's first. That's my reminder, but LDR X11 SP, I think I do it this way. So SP plus 8, this is the post increment version. So I load that thing back, update this counter so it pops the blank space and X11 off, and then we go on with the rest of them. Okay. So let's say X11 holds address of string to look for, and I can okay, so that's my input. I guess search string. Tap to walk through dictionary. Holds address of search string. Okay, and then the outputs. We get 0 if it's not found, or the address if it is. And then let's see, start moving X0 to X11. Yeah. Yep. All right. So the address, if you find it, X10 plus 16, that's 2 words down. So I don't think I really wrote down our format, did I? The pointer's first, then the string. So this points to the word address. Word address of found entry, or word address. Okay. Yeah, and so start by moving X0 to X11. Well, that might make sense before this even, huh? Move X11 gets X0. Okay. Now X11 will not get destroyed by those things, so I think this becomes unnecessary. Well, no, we're going to have to move it back. So move X0 gets, well, yeah, we better move it back. Okay, I got to think about the second time through the loop, right? Okay, So X11 is always going to have that. We'll take a fresh copy every time. Compare X0, that's fine. Add X0. Well, I feel like something's missing. After the search, move X11 back into X0. Yeah, it's not the search so much. It's the stringy queue destroys X0. Is that all we got to do? Am I doing this right now? It's almost so easy I get confused. But before X0 was subject to change, now X11 is always right. So I got to watch that we're using the X0 goes to string queue. The result is also in X0. We're loading something relative to the pointers. We're going to the next pointer and then continuing. Otherwise, we get here X0 equals X10 plus 16. Well, that seems right. I guess we don't need the string name anymore, so that should be better. All right, that feels better to me. Let's save it. What the heck? Okay. Okay. Yeah, this is the thing that happens to me a lot. It's like 5 more minutes somehow, but a fresh 5 minutes is not the same as the 5 minutes at the end of the 2.5 hour session. So it's an illusion. I know that. When I was coaching teams in person and more actively, it was very common that somebody might be trying at the end of the day to get something done. And it's like, just set it aside. They come back the next morning and it's typed, it's done. I feel like that happens to us often enough. All right. Now I just want to make sure our tests cover, okay. Yeah, let's just walk these tests. So search an empty directory. We create one. We load an address that's not there because the directory is empty, and we should get a 0 back. Yes. Search word not found returns 0. Okay, this is the one we were working on, and it goes through a list of 2 items. That's fine. Search word found. Okay, we're looking for the first one. I'm kind of tempted to put that second. It shouldn't matter where. Actually, let's add another one. Let's just put it in the middle. What's this? That can't be right. Unless we're just using it as a junk entry. No strings. I mean, it really should be NL. Okay, so yeah, we'll make this test a little better. All right, so now we're searching for NL. It's going to be in the list. That's fine. We should get back X21 plus 16. So I guess that's saying the second entry in the list. Okay, let's make sure that's true. No, it's not. Okay, what have I done? I was going to switch it when you made it first work. Yeah, I think so, but what's going on? Okay, let's take this one out. This line out. Okay, so it is adding the extra dictionary entry that's throwing it off. Because I worry that may be, well, if you only you don't go through the loop, right? You find it right away. That's sort of a potentially different case. I mean, the same case should cover it, but it appears we don't. Now, does that change the assertion, I guess, is the question. And I know this is bad, but it's like a weekend away and I forget what we have. So X19, X21 is the system dictionary. All right. So X21 plus 16, what was this before? Oh, yeah, no, the 16's not right. Yeah, you're right. Because now it's 3 bytes further away, so it's 40. Instead of 2 8s, it's 3 8s plus 3 8s, 40. Because the header for sub takes 8 bytes, and the header for NL takes, or I'm sorry, the header for sub takes 24 bytes. The header for NL takes 24 bytes. And the pointer was the first byte is, or first word is the pointer to the dictionary entries. The second word is the string address. And 16 bytes in is the word address. So if it was this plus 16, that got it there, but we're adding another 24. So I believe 40 should be right. And I also think, you know what? It may be time to fix assert equal before we go too much further. Well, okay. Let's make a little tiny picture. So we got 0, because we're pointing to 3 bytes before. Well, we have the 0, 0. Then we have, I'll say 104, the line number. And the string is add. And the pointer is pointer to add code. All right. The next one points to 107. NL, pointer to NL code. Next one points to 110. Sub, pointer to sub code. And X21 starts at 113. Oh, so this is really like -8. Not sure it matters if I put the minus in or not. Hey, I'm using Xcode as the editor, so we're programming in ARM assembler, but using Xcode, which I think I've been through 2 editors already. One couldn't update, and I don't know what the other one just annoyed me too much, maybe. It mostly helps a little bit, but it's really bad when you paste it, redoes the indentation. Like what? Like what business is yours if I put tabs there? But anyway, all right. So I think 113 is where we start X21, I believe. It was starting here, and so we had to move down to. Now it's here, and I think we got to move back 8. But you know, like the third time I've argued something, it's kind of makes me feel like it's suspicious. All right. If I add another one. Yeah, I think I'm okay. All right. Well, certainly we're in green first. Okay, so let's see. Chandu 16. So welcome. We're working on a assembly language interpreter for a programming language that's very much like Forth, which is a simple stack-based language. And we're doing the piece that says all your words, which are sort of like your methods, should be in a dictionary, so we can search for the dictionary when we try and find something. If you want more, let me know. I'll go through the whole setup of things, but I think that's enough to kind of see what we're doing so far. All right, x21 is the start of the last element. Yeah, so if x21 starts here, like before, take out 113 down, we had x21 starting here at 107, and it matched right away, so it needed to get to 16. Now we're saying let's start it down, so it's really, instead of being plus 16, it's sort of like plus 24 minus 8, or however you want to think of it. But we're starting x21 here. We don't find the word. We back it up 3 words. We back up the pointer to it 3 words, but the starting point always stays here, because that's the global pointer to this. So yeah, it's minus 8. I mean, if you think it's more clear this way, I kind of wanted to argue it was, but I think that's probably more clear. I changed it to a sub, but make sure it still passes. Okay. It's not an ideal way to find this. I'm starting to feel like, there's starting to be enough things juggling around that maybe this documentation is what I need more of, just to remind myself, like, x19 is the virtual stack pointer, x20 is the virtual program counter, x21 is the system dictionary. It's like all these things together. All right, but we're green after not being green for a while on last week, so let's commit this. Make dict search work. Okay. Okay, so I think, well, let's go to the to-do. Let's take credit for this one as we do it. March now, 304. And this is, I think I just called it dictionary. Okay. So, okay. That I think we'll take as done. Update test to use dictionary and secondary macros. That might be a good thing. Data stack to a bigger size. We'll do that as we need to. Should VSP point to the last element to the next 3 slot? I don't know. You can make either one work, so it's kind of up to us. Test run interpreter on a primary. We did that already. That was a couple sessions ago. Note that our arithmetic operations don't check for overflow. Yeah, that's 1 and 5 is sort of the same thing. The most negative number, you're kind of vulnerable depending how you do it. Should VSP point to the last slot? Okay. Yeah, those all seem like the update the tests, that might be worth doing, but I kind of feel like if we can get the system dictionary properly going and get the compiler stuff working, like once we have the compiler bit in place, which is pretty primitive, I think at that point we'll be able to test just about any dictionary, secondary, all that stuff. The dictionary structure will be tested by that, and then we'll be able to test other things more directly. Now, it may be worth fixing up those tests for this, but the one that gets me, and it's hit us before, it was this assert equal. Like, we didn't know the answer was, we just knew it was wrong. It doesn't tell you what it should be. And I don't want to replace printf, I guess. Ugh. I can see why they wrote printf, though. I'll say that. But let's go to our assertion stuff. Okay, I think I'll just close this window. Our macros and our assertions. Okay, so assert equal. it compares and it prints a fixed message, pass or fail. But really, if I fail, I would like to have more information. And I don't know if we, do we test search not found when there are elements in the dictionary? I think we did that last week. Let's make sure. Yeah, so yeah, we had elements here. This one, the one that was failing this morning, actually, the first thing. So we're testing NL in a dictionary that doesn't have it. I don't think there's much there's a difference between a dictionary that's empty and one that has one thing in it. I think two, the jump from 1 to 2 is sort of significant or not. We talk about 0, 1, many. You could argue because many forces you to put a loop in and 1 does not. You might say, well, we haven't tested the case where there's only one entry in the dictionary, but I kind of feel like if it works for many, it's going to work for 1 on a test like we're doing. So, yeah, I think this will be close enough. All right. So these prints, I mean, I would have loved it if it said fail, x0 equals this and x1 equals that. Even if it was decimal or hexadecimal, I don't care. Just to get that value in something I can, compare and look at would be a good step forward. So I'm kind of thinking that might be a nice thing. I believe it'll help us at least once in the process of doing the compiler stuff, which is more of a bigger job. And I didn't really lay it out much. I took some notes this weekend, but I don't think they don't really make a coherent story, I think. Notes from the book I've been using as inspiration. So let's see, what's 2:30? So I would like to at least get some sort of message out after a failed message. And yeah, so he just does print. Do we print numbers now, right? We have print num. So this is doable. Okay. We don't have string copy. It's like, oh my gosh, everything you need. String length, string EQ, print, and print num. Deck to string. Okay. And what does he do? Pointer to his string. Right. So he declares his own buffer. Let's find that. This. Okay. Our test could do the same sort of thing. I think that's actually the right thing to do. Let's take this. So I'm saying we're going to use some memory up here. Okay, this is back to text. I probably had that twice. No? Okay. Let's make some local storage. And this is fail full message. Okay. Print and hex. Yeah, I have string to deck. I'm going to cheat and just do string to deck. But you're right. We would, most of the time, hexadecimal would probably be better for us at this stage in our life. We do have, did I delete it? Maybe I closed it. There is a calculator, and we have used that before. But I think if we saw some of these things where we see, we're trying to get the right, like we had off -8 or +24 or whatever, I think we'd kind of know. But yeah, I'm just going to, for now, I think step one going forward, I guess, is what I'll say. Now, can that work? I think I'll move these. Well, no, they don't have to be. If I do this right, in some ways, I could just have this here and then slap stuff on the back of it. Yeah, it wouldn't be hard. And honestly, I mean, I wish I could say this, right? %x, %x or something, get a printed hexadecimal message, or %d, or print them both wouldn't be a bad thing. But I'm just not willing to put that much effort into my print at this point. I haven't really worked out in my mind even how we handle strings. Forth had a way of doing it. It seemed a little clunky for us, maybe, but I don't know. We'll see. All right. So I think what I want to do, I think I will do that. I'm going to move these up. They're going to be down here, but I'm going to make this one, I'm going to put it up here. Okay, and this is failed message. Now, some of this may mess up something. Well, and this should be hell. It's local. How about, okay, failed message. How about I call it L fail full message, L fail variable. L fail data. I don't know. All right. But the point is, I'm going to put this. Now, how's that going to work? Yeah, I have ASCII. No. Maybe we need to do string copy before this. Ugh, I don't want to do that. So what I was going to do was use this for the message, but arrange carefully that the bytes following it are the ones we want. And I think that's still doable. Well, it's like this. X0 equals. All right, at that point, if I slapped in data here, it would all be fine. Okay, but you know what? I think, oh boy. All right, so what I want to do is write x0 and x1 in the assertion message. Okay, now to do that, maybe we just do need string copy. Because we're going to have deck to string puts a string out there for us. If we had string copy, we would just say string copy that to that address, and it would all be good. Yeah, I don't know. I'm trying to balance out things. Maybe let me describe what I understand on the compiler aspect of this. Okay, so I'll add elements and talk through it. So, one thing you have, where's this? Well, shape this format. No, I thought I put a new one in. Okay. Well, let's just use words. Dictionary. All right, so we have a dictionary. That's got all the words in it. It has a search method, and that's going to be handy. Another thing that comes in is the input. Okay. Now, at some point, somebody says dupe one sub, you know, and somebody's got to parse that, or at least tokenize it or something, break it apart into words. Now the question is, should you just take dupe one sub and just parse that into 3 tokens, a dupe, a one, and a sub? Or should you just go for dupe and then parse the rest if somebody asks for more? Okay, so you have this tension in how much you want to do. The more general one is probably the second one. Just parse what you need, and then you have the flexibility to decide when and how to parse the rest. I'm kind of willing to forego that. Okay, so let me get the sort of defining example for what we're trying to do next. Is like we want to make a dictionary entry, and they fourth uses this colon operator. So you do fourth, and what are you describing? Well, I'm going to invent a sub one routine, and the definition is dupe one sub, and then at the end a semicolon. Okay, so print the fail message. Yeah, we could do it that way. I'm sorry, I'm just that much delayed on these messages. Print the first fail message, then print the register name, then print the dex string, then print the second message. That's true. We could probably get by without doing string copy this way. All right, so I'll finish this little discussion and then we'll come back and do that. Okay, what else is existing? Well, there's we know there's a data stack because things like dupe and sub work on the data stack. There's also a system stack because we're already using that. When you call start2d and you call recursively to start2d, we're pushing the addresses on the stack, and that's good. There's also another stack, and many systems will blend the system stack with the other stack, and we may be able to do that. I'm going to call it the control stack. Control being like control structures. So if you do an if statement, if you got if else or if, you have to push the address where you're going to update the branch instruction. So we have to go back at the end and say, oh, I want to jump past all that stuff I just entered. We got to go back to that old statement and say, okay, patch it here. And there's a stack for that. We may be able to blend it with the system stack, but conceptually it's a separate stack. Okay. And I guess you could only blend it if you promise to not do some pieces in one routine and some in another. You'd have to do them all at the same level. It's not going to get that deep, so I'm not going to worry about it too much. All right. I mean, I could see writing a few levels. Even 10 levels is probably more than you ever want to see. All right. What else have we got? Well, at some point, this gets tokenized or converted. I don't know. I'll say tokenized input, but it's hard to say. Okay, and then the dictionary, let's put it in as if it were text entries. But okay, so the dictionary is like pointer, string, address, and that repeats. Okay. Why they default to 45 there, I'll never know. Why are you so far apart? Oh, you're not. Okay. All right. And so the deal is when you get a word, okay, so if we were in some sort of direct execution mode, which these the fourth REPLs often provided, okay, you might type this, no colons and semicolons. You might just say do one sub, and oops, we wouldn't have sub one. That's nothing yet. You would just have this. If this were your input, dupe one sub, the system would go dupe. Oh, I know how to do that. I'll take the top of the data stack. I'll duplicate it and return. Okay. What about one? I know how to do that. I'll push a number one. Sub, I know how to do that. I'll pop the top two things and do them. And so every word just gets executed as soon as it sees it. Now, whether we execute one and then do the rest or all that stuff, well, that's a decision. But at some point, the interpreter goes through one at a time and decides, so kind of regardless of whether we're getting an input or a sort of pre-chewed input, we just go through and do these things. But this becomes different. So with the colon says start compiling. And what it's going to do is it's going to read the next word and say, that's my name. So it'll create a new dictionary entry pointing to the last one. It'll take the string that it reads next. So this kind of argues against tokenizing immediately, but it takes that string and puts that in the dictionary. And then, this is going to be a secondary. It's a user definition. So it's actually held in another block of space. Let's call that, I don't know, the pool. Okay. So it's going to allocate the next entry in the pool. Okay. And that looks like pointer, and we know all secondary routines point to start 2D, the routine that would start secondaries. And then they don't need a string, they just need the commands. Address of dupe, address of one, address of sub, and some systems 1 is actually a command and not a number constant, but whatever, we'll make it work. Okay. And so as colon does its job, it says, read this word. Okay. It reads it. It puts in the dictionary. It allocates a block from the next slot in the pool and sets the address to that. And then the dictionary entry is there. Well, no, I'm wrong. Okay. This is why I'm thinking these things through. It really does need all the header stuff too. So it's got to have pointer to prev dictionary and the name equals sub 1 in our case here. Okay, so let's make some room. Okay, so if you come in with a new definition, colon's going to be working from the pool space. It'll say, okay, next entry in the pool is I need to take the pointer to the previous dictionary and move it forward through, take whatever it was and put that here. Then I'm going to read the name, sub 1, put that here. I'm going to point to start 2D because all secondaries point to start 2D. And now I'm waiting for the rest of these inputs. Okay. So the dupe here, unlike over here where it's like read the word dupe and execute it, the dupe here is supposed to be look up dupe in the dictionary, which combines the pool and the system dictionary. And when you find it, it happens to be over here, put its address in here. Okay. And so the behavior is different. This is execute it. This is look up its address and append it to the pool. All right. And so I think, basically the solution lots of them use is they have some bit marked somehow in the dictionary entry that says this is an immediate word. And so colon has that bit marked, and colon says, I'm an immediate word. I get control. I'll decide what to do. Okay. First thing I do is allocate space. Second thing I do is read the next word. Third thing I do is fill it in. And then I leave myself in this dictionary mode. I'm going to grab the next word and put it in the, look up its address in the dictionary and put that address here. And all that stuff is under the control of colon, nothing to do with evaluation in REPL. So I don't know, there's enough, like we've got this piece kind of together. We haven't really addressed building a full secondary. We've got a data stack. We've got a system stack. The control stack is going to be addresses in our pool and nothing else. And like I said, it could probably be 10 items, 10 slots and be fine. We haven't done input and tokenizing. I want to split this. So one part of input is just reading stuff from the terminal. We don't handle input yet. We do handle output. And then the second part is once you have that input, where are you gonna put it and what are you gonna do with it and manage it and tokenize it or whatever you got to do to get words. Okay, so this to me is, I don't know if you want to call it a compiler or a REPL or what the right word is, but it's sort of the next big piece I want to do. And once we have this, I feel like we have the core of everything, even though we only have a handful of words defined. I think we have dupe, sub, one, add, multiply. Is that it? Maybe might be a couple more. Address a push. Yes, in the case of one, well, some fourths put one in as a standalone word because every base uses one. But yeah, in our case, the implementation we're doing, it would be that address a push and a literal one. Okay, so assuming the way we're going, yeah, that's true. All right, so this is compiler / REPL, and I want to start this really, really much. I'm willing to leave input, reading the input aside, and just if we had the if we start with the string that you would get from the input subsystem, that's good enough to get the compiler going, and then next after that we'll try and get real input. But I like your idea. Yeah, load from a file would be a darn good thing to have. It would get very old typing anything of any size. So yeah, we'll need that input either from terminal or file. But a REPL is a handy thing for us, especially if you can mix it with the file, right? So you would just, open a file. Now you have some definitions, pop in a few trial values and stuff like that, and your REPL, and you can go like that. So, yeah. Now, in my mind, I'm not clear if I tokenize the whole input. Oh, this is word colon, word sub one, word dupe one, a number one, word sub, and symbol semicolon. Do we ever need? Does any immediate value need to override that? And I think in some force the answer is yes, because the compiler, the colon command does some things, but if it gets a string, it kicks in a different immediate command. The ifs and all that, I didn't put any in here, but if you have an if, it actually is an immediate as well. And if says, oh, I need to do this address patching stuff, and pushes stuff on the control stack, and then the end patches it, or the else, or whatever. So, all right, let's go ahead and work on that print equals following, or assert equal following your suggestion there. We're going to skip the string copy and we'll just use the print. Okay, so AsUnit and that. All right, so this can be an ASCII Z then. Just like that one. And it can be here. And let's just do fail message like we did before, except I'm adding the else. Pass message, failed message. Okay, make sure this works. Already, oops, that was me. Failed message not defined. Oh, changed the name on me. Okay. Failed. Why did it fix up not sufficiently aligned? Oh, interesting. do that here too. Because my messages might have odd numbers of letters. I don't know if they do or not, but apparently one does or the other one does. Oh, this should be, I took out that new line. Okay. All right. So I think I like your suggestion the best. So let's pull this up into both branches. So this is sort of a normal refactoring. It's just it's harder to follow in assembly, but what I'm doing is I have an if with two branches that rejoin at the exiting point. One falls through, one jumps there. But I'm going to pull this and move it before the branch in both cases. And then because I'm already doing it in both places, get it out of there. And I'm sure I could arrange so that the last print covers whichever thing is coming out last, but I think from a conceptual point of view to follow this is going to be the best way. Excuse me. All right, so address X0 L message. Okay, so failed, I want our failed message to be X0 equals ASCII Z is fine. Yeah, I don't think we do. And then we're going to have the decimal to string gives us something, and then I need another message that's X1 is going to be ASCII Z space X1 equals, and then I think and new line. Is ASCII Z X1 equals /n. Okay. So that I think gives us the pieces. All right, so now address X0 L failed message. All right, we can. Oh. Well, we can't lose track of X0, right? So X0, X1, we really need to keep around, but print consumes them. So we have to do our little trick again. Let's store X0 in SP pound 8. Store X1. Let's try that again. SP pound minus 16 bang. It's not X0, it's X10. Okay. X10 equals X0, X11 equals X1. Okay. Now we're kind of set. All right. I don't know. This is going to get a little big. Okay, so assuming we have these two variables, we got to pop them at the end. And I actually think I'll open up dictionary for that. just for my notes. Okay, LR that. And then we got LR. Okay. So I think at this point, all I've done is push X10, X11, set them to something because I own them. They're callee saves, so nobody's allowed to change them on me, and restored them. So everything should still work. Good. All right. Now I think I'm free to do stuff. So X0 L field message. We need to call our decimal to string. Address. No. This is move X0 equals X10 because we want to print it. And then branch to decimal to string. Let's go find that guy. All right. And he returns X0 as the pointer. So we can make use of that. Notice that's the same thing we do here is we load X0 gets the value, so we can just call print. That should print that one. X0, now we got LX1. Blank to print. And get the last one in. LNO, okay. LNL and print. Okay. And then the equivalent of this, but for the other one. Get X11, print it, convert it, and print it. Okay, well, that's not so horrible. All right, so well, it should make and pass, but we want to make things fail so we can see what's going on. All right, so let's muck up one of these since we were most recently here. We had dictionary tests, not the dictionary. All right. Well, let's just make this 7. No, let's take one that's gonna do something. X1 assert equal. Okay. We had 16 before, right? Let's retrace our steps there. Okay, so now I'm testing my test by running it manually. X0, X. Oh, thank you. Yes. Well, let's see it fail. X1 equals 4. I guess that's kind of one of those random things, right? This should be X0 gets X11. Yep. Right, so I was apparently printing whatever it felt like returning. Okay, that's better. Yeah. All right, so we have these two different values. They're off by 24 is kind of what we saw in real life. And then we change this to be -8. And they should pass. All right, I'm going to change it back for a second. I'll just make it wrong. I want to tweak the messages a little bit. I think There's kind of like too many dashes running around, so I'm going to make this one a colon. That's not so good. 033, that's part of the escape code, I guess. Not quite clear whether I want this red or not, but I definitely don't want a dash. Did I not save? I did. Okay, fail. Boy, I think they would all look better red, wouldn't they? Let's pull in this. Well, actually, let's move this down to here. Message end. I think that's better anyway. All right, so now that's there. Fail x0 equals x1 equals. I think that's better. Okay. And let's put our dictionary test back. Should be -8. Good. Okay, so make assert equal tell x0 x1 when it fails. Well, for that 20 minutes of work, I'm sure we would have saved ourselves some time in debugging with that. Okay, so good change. It's hard to kind of balance out moving forward on everything. You know, we haven't really done much in the language we're writing, the fourth, this little 10th replacement language. But that one's kind of the furthest back. We haven't done any input stuff, but I'm trying to move things forward so our build system and our assertions and all that kind of get improved every little bit along the way too. Alrighty. So I guess where that leaves us is I want to start this stuff, and I guess to make this happen, there's kind of two pieces. Yeah, less time in the debugger. Gotta be a good thing. It's been a while since I really did any hexadecimal matching up stuff and all that, not till this project. Okay. So the state we have now is we have the ability to build a system dictionary that has all our predefined words in it. We have not yet built that dictionary. Once you have that, we haven't built this pool. I could stand a better name for it, but we don't have a space for that. But if we did, we sort of could use what we have already to do these words if somebody filled them in. And I don't know, we'll have to see how that goes. Okay. So I think maybe the next step, I think things will be easier I think whatever we're doing to tokenize needs the dictionary, needs to be able to get secondaries. Is that true? No, it's not really true. I mean, the simplest thing I could do would be go through, one thing I could do is go through and break these all up into separate strings so I knew how to feed them. Is that helpful? I mean, I'm kind of assuming you'd have word space, word space, word space, maybe quoted string space, end of line, or maybe empty string, but end of line might be handier. One way or the other. Empty string probably is okay. Okay, thanks for joining Ridogron. Or Groan, however you want to say it. Yeah, this is this can burn your head enough for one day quickly. All right, take care. All right. So I think let's get the system dictionary populated, then tackle creating a secondary. And I don't know, maybe we should let this colon command drive creating that secondary. But what that'll require is we do something to know. We have to know whether a command wants to immediately execute or whether it wants to it wants to be control further execution. Now, if we defined if or one of those, right? If you defined an immediate command, how would that go? I don't know. And I don't have a good solution. All right. Bye-bye. I don't have a good solution for immediates. Now, the old school way, because they were only doing like, I don't know, 4, 5, 6 byte headers, maybe less in some cases, like they would just take a spare bit and use it. The bits we have, I mean, they're already kind of biggish by their standards because they're 8 bytes each. These pointers are 8 bytes, the string pointer, the address pointer. All these addresses are 64 bits. The only spare bits we have is we know the bottom 2 bits of a pointer are always 0, 0. Just because of the way they require. Well, is that true? We can make that true. We start things on an even boundary and then make it, I guess the bottom 3 bits maybe 8 bytes. But the bottom bit is certainly not used. The addresses we create in this pool are always going to be 8 bytes long. So we could just start on, an 8 byte boundary, and we would know that we could set that bit 0 or 1. So one possibility is use a bit in the dictionary searching thing, and we would have to clear it in here. Our search, when it got, where's that? This statement, it would load this. That might have a lower bit set, and we would have to clear. We'd have to and this with, not -1 or however you do it. But we'd have to find a way to turn that bit back on to a 0, and that's doable. It adds one instruction to our dictionary loop. The dictionary loop is more compile time or immediate execution time. It's not really runtime of a secondary, so I don't think it's a horrible cost. Another way to do it would be maintain a separate structure that's sort of, maybe it's the list of tokens that are immediate. And then you would just skim through that list looking for, the address of the word you've got. And if that address is in the list, then we know it's an immediate. Yeah. Or the easiest, right? Yeah. The true easiest would be, why am I saying this is 3 words? Make it 4 words, put in an extra word, and then I've got 64 bits to fool around for anything I want. Although I don't really think it's a long list. All right. So, okay. And then, all right, then a separate thing. There's the notion of coroutines, and, we're exploring sort of an alternate mechanism here with this threaded code stuff. If we do the full optimization on it, it's like you don't have any procedure calls at all. You just have lists of stuff and you're bouncing around between them and all that. That's sort of an alternative procedure call. The coroutines are also sort of an alternative procedure call. And when I think about the way we're going to do things, it's going to be read some input, look it up, and let that word tell you what to do. And if it's an immediate word, it's going to take over some aspect or change some aspect. If it's another word, if it's not immediate, it's more of an execute word, and we would just do it. And so the thing, the next step, like say it does it, it's going to read the next word, and it's like you don't have to read the whole word or the whole line and turn it into words at once. You could just do it as you go. And that's more of a coroutine setup, because you're sort of like at the end of the word reading, you're going to say, okay, continue with your compiler stuff or whatever. That's probably one, it's a little tricky thing I would love to play with in assembly language, but maybe it's just a little out of our scope. So, if I break these things into, like, what if all I did was turn every space into a null byte, excuse me, and then maybe leave one extra null byte at the end? Would that be a good way for us? Or yet another way, I guess thinking of alternatives, right? The result of tokenizing could be a list of, maybe I do that and I put the index of the start byte of each string in a list somewhere. And then I just go through and say, oh, first word, that's at column 0. Second word, that's at column 0, 1, 2, 3, 4, 5. Third word, column 7, and have all those, as opposed to scanning a list. I don't know. Yeah, maybe that's the way to go, is scan it and convert them, and we can replace that module if we need to. So let me draw a picture there. We'll get, let's take good old dupe1 sub. Okay, and it's an ASCII Z. Let's assume it's followed by a 0 at the end. I think that's reasonable. So what I'm saying is I would convert that. I gotta do this. I don't know if I have a down arrow. Okay. And that I would turn it into dupe1/0, 1/0 sub, and then the ending I don't know. Maybe /0. Maybe I keep track of the length. It wouldn't be hard to get the length of this. Okay, let's keep going. Or this. Like, what's going to terminate my loop that's going through and reading things, right? I should have something that says, like, next instruction. And it should read this string. And it's going to read the string to there. And we're going to give it a string. It's going to say, okay, I'll take that string. I'll look it up in the dictionary. And then when it moves to the next string, do I have to know the count? The index? So in this case, dupe is 3, 4, 5, 6, 9 letters. Okay, so the read loop would be like, start at 0. Are you greater than the length, which is 9? 0, 1, 2, 3, 4, 5, 6, 7, 8. I guess greater than or equal to the length. No. But he's not going to start character index. He's going to start with a pointer. But I guess if we got the length, we could find out the pointer there. Or yeah, so it's a tricky little thing, right? How do you detect the end of this? I mean, I'm going to have an input buffer. I'm assuming I can modify it to one of these modes. If I know the length, maybe that's okay. I'll take the thing you give me. I'll drop in. I think we'll start with executed commands. So you can't define anything yet. So that'll simplify things. We'll need the system dictionary. But if we got this done with that, right, we would have something where you'd have system commands and you could go in and type them and do stuff. That's actually kind of a thing, right? It's a small application thing. Yeah, executed just runs. So we just need to get the name, look it up in the dictionary, and execute it. Call call whatever the run interpreter or whatever we decide to start the could be start 2D, but whatever it is, we do whatever it takes to execute that primitive, or that word, I should say. Right. So I guess we could, if I did this, I'm assuming I'm getting a buffer. I'm going to put B's in after it, or maybe it's question marks. No. So I've got a buffer that accepts either a line or a gazillion characters, and you come in. Somehow somebody read something from a file or a keyboard and said this line is dup1 sub, and it's got a 0 at the end because my strings have zeros, C style, and it's got random garbage after this. But I could say put in the sentinel value and do this, and then my loop is read the next word. If it's empty, then exit. Otherwise, execute the word. I think that's the way to go. So we'll do this one. Okay. And so input to this thing is a string in a string buffer. All right. And I guess this is kind of the REPL, right? I mean, this is the thing that's this is the read, and then eval is the call, and then print is whatever prints you do, and then loop. So I guess this is a REPL. All right. Good. So let's go with a test. So the test is, I guess if you put in dup 0 and you, I'm trying to think of something we can do without mucking up anything. I guess the question is, what do we have implemented? Dup push, well, maybe it's good old push. That might be a good, well, that triggers more work. Ugh. Yeah, we'll need something to clean out the pool. Well, I think this is more like the input area, but input buffer or something like that. You can see why somebody would want a 1. A 1 command. Let's do that. Let's make a push 1. I don't know if I want to leave it in. Well, I think sort of the controlling thing on the outside, if there's like a total crash, maybe we restart. I don't know. We'll have to see what we think. I almost want it for testing purposes. Okay, I'm overthinking. I need to get started. All right, this will be an assembly file. And I would say it's REPL tests. Okay, and the test I want to do is something like, well, I want to give the string push 1, which is a garbage testing command. but we'll use that. And then I'll put the 0 byte in explicitly. And then I call REPL. Maybe it's just rep. we just want to read. I don't think we don't do an implicit print, so it's really a read eval. Actually, maybe it's just eval. Okay, because the read is going to be kind of outside this. This is like, you give me a line of text, I will do the thing. And the thing may be evaluate and execute, or at some point it'll be evaluate, compile, and keep going. All right. And then at the end of this, we should see 1 on stack. Okay. I don't think that's too bad. All right. So I want to define, kind of like our dictionary test. Do we define our own at one point? Well, we can make one like this. Dict. All right. Let's do align to text, align to. All right, then, oops, no. Well, okay, somewhere we're going to do test start. And the test is push 1 leaves 1 on stack. I don't know, that may not be the right name. Test end. It's kind of, I mean, I'm not really mentioning eval, which seems off to me. So maybe it's eval of just push 1 leaves 1 on stack. Okay. All right, so we're initialize our dictionary. We're going to add push 1. And this is push 1. And the routine push 1 is going to look a lot like one of these. Push. Yeah, it's almost this. We're just going to move 1 in first. Okay, I'm getting lost here. Okay, so that should be a routine that pushes a 1. We've created it. All right, so that covers that side. The next side is I need some data area. Data. I'll align 3. I'm not quite sure if this that P2 align might be a better choice. Let's find those. 2, 8. Let's P2 align 3. So this third power of 2 to the third is 8. So that's our boundary. Okay. And then we need input buffer. Yeah, 100 is more enough for now for a test. Okay. Let's see. So we're going to yet again. I want a string copy. The universe is telling me something. All right. So what I'd like to do is copy. I just want this string. Well, maybe I don't even need that. I'm going to kind of limit us to one space for now. So if let's just put it in there. ASCII Z push 1. Okay. And some extra stuff. Yeah, let's get this kind of laid out and then we'll take the break. Because I think I just want to get this address into X0. Sorry, which is load address gets L input buffer. Okay, so that's my input. This is going to be branch to eval. And then this is check that 1 is top of stack. And really, we should check that stack has 1 entry. Okay. Yeah, let's take a break. We'll come back and we'll start working on this eval test and see where we get. All right, thanks. Okay, welcome back. Let's see, is this accurate? No, we already did this. And this is kind of a big area. One thing is eval for a 1-word input. Eval for multi-word direct execution input. All right, that'll get us started. All right, so we got the input buffer. I think we also need some stack space. Eval test stack. Maybe 80 is 10 words. That's enough for now. This probably wouldn't hurt. Okay. And this load address. X19 is our virtual stack pointer. We'll point it to that. Okay. So I've got a data area set up. I've got an input buffer. I call eval. Now I want to make sure X19. Well, let's load address X1 with this. Okay. I guess I want to check the stack size first. right, so if I take, maybe this is x0. I'm going to take the start place and then add x0 equals x0 plus 8. Now, somehow I have to end up with x1 having the expected value. So that's this plus 8. And then x0 needs to be x19. Okay, so I'm trying to say the stack pointer should be Eval test stack plus 8. So it should have moved forward 1 position. Now, I keep forgetting this stack thing. It starts pointing to where it's going to write. I guess it doesn't matter. It should be 8 bigger. One word. We're in 64-bit processor, so that should be that. The stack has 1 entry. And then what do we have in here? We have a top. We don't really have one. Okay, well, I guess we can look in the memory. Address x0 gets, well, can I say the contents of x9? I guess Eval text stack. You know what? I'm going to make this 42. Let's make this 42. Let's call it push 42. It really is just a little testy thing. Okay, so push 42. Let's make sure x this be assert equal. All right. So we create a dictionary. We set up the stack pointer. We set up the input buffer. Call eval. It should have run our little program, push 42. So we'll maybe this one makes more sense first. So we'll look at the first entry in the stack, make sure it really is a 42. Then we'll take x19, compare it. That's the actual value. Then we'll compare it to the address of the test stack. It should be that plus 8. Move the contents that x0 points to. In this line, x0 is an address. Oh, yeah, that's not right, is it? I want x19 to be equal to, oh, this is the address. No, I think I'm okay. This will load the address or loads the contents. Can't do both. 40, yeah. Oh, x0 is the address. Okay, so load x0, contents of x0, right? Okay, so look in the address and see what's there. And then we kind of repeat it. Okay, now we're calling methods, so we need a prologue. We don't have one in here, but we have one in here, I'm sure. Oh, these aren't either. Yeah, they should be, I think. Oh, test start does that for you. Okay. Well, how far will we get? So where's our dictionary pointer, right? We need that. Oh, I guess that's going to set that up. X21. Okay. All right. And then we don't have an eval yet. Let's put that here for now and just do a return. Okay. We do need a test header, which I'm kind of tired of writing these, but I think we should somehow be able to make a macro for this. Well, I would say this should come after that. Okay, this is now REPL tests. Okay, we only have one test. And we need our makefile after all. I don't know. It would be interesting if a passive variable list. Okay, so REPL tests.o depends on REPL tests.s, and dictionary.o and $macros and $test macros. REPL test.out depends on REPL test.o. REPL test.o does not depend on dictionary.o, but the running of it will. ASUnit interpreter, yeah, this stuff all. Okay. Where's our test? Oh, I didn't put it in the list, did I? Too many. Okay. Oh. Oh, this depends on REPL tests. No rule to make target REPL tests.s. REPL tests. I guess. Well, how's that different than this? REPL tests.o depends on REPL tests. REPL tests.s. No rule to make REPL tests.s. to make target REPL tests.s. Make sure I've checked this name, REPL tests.s. Oh, this REPL star. Where am I? Oh, haha. Okay. As usual. Now, is there a good way to do this? Can I change? Okay. Let's delete this. New file. This goes up one. REPL test.s. Okay. Try that again. Okay, that's progress, believe it or not. All right. I don't have any includes. Okay. Yeah, we'll need all those. Once you get to the highest level, you pretty much know you're going to need everything. All right. Okay, hey, there's some stuff for you. So 320 versus 328, so the stack pointer did not move. And we happen to have a 0 on the stack because we did a fill, I guess. All right. That feels good to get that far. It shouldn't be that hard. But sometimes I don't know what I'm doing so well. Honestly, I got so lazy using Xcode with Swift, and it just doesn't support a lot of stuff here. It doesn't do things automatically, and I'm probably creating trouble because I don't want to let it put the files where it wants to. Okay. So, well, we certainly know we don't call it. Yeah, success. All right, so I guess the thing Eval should do, right? We have to take the next string, look it up in the dictionary, and execute it. Now, we haven't tested the corner cases yet, but all right, so eval, evaluate a line of input. The input is x0, input, words separated by space. All right, and then, well, okay, let's input. Okay, so eval. Well, let's just start with 1 and see what we get. So we have dictionary search. I'm going to be brave and close that. Let's take dictionary search. We created the dict search one that says find the address of a search string. Okay. So I guess we're not going to keep track. We're going to treat it as a pure one-step move. So, you know, I'm not going to track the pointer to the input or any of that. I'm just going to handle one word. We'll grow that, but that's a starting point. Okay, given this, give me the word if you got it. Okay. So, well, we have to call branch dictionary search with x0. And we do have to provide this. Function to copy characters until you run into. I don't. We will. I'm keeping this test to one word, but yeah, I think what I expect to do is write a test to go through a string and replace every blank with a 0 byte, and I think that'll get us what we want. That sounds like a C function. I don't know if it is, but it certainly could be C-like anyway. But for now, we only have one word. It's 0 terminated, so I'm just going to treat it as the word. So now we'll have a REPL that can let you type one word per line. All right. We need this. I don't think we need X10 per se. I suspect it'll need stuff by the time it's done, but all right. And then the trailer. Okay, because we call a word, we call another routine, we have to at least store the LR. That's the subroutine call link. Okay. We call dictionary search. We get back an address of a word. Now, where's our dictionary macros? Okay. We have a name of the address, code address of code, link, pointer, this. And then what our find returns, did we say? Word address of the found entry. Okay. So, Well, I gotta go to interpreter. Okay, excuse me 1 minute. Sorry about that. You can't neglect doctor calls.
Yeah, sorry. It's either 9:40 or 10:10. Okay.
Okay. So this mutilates the data stack, so we don't want this one. But if I get the code address, right, that should be what Start2D wants. X20 is VPC, initial X0. Okay, that's process. X0 is the starting point of the secondary list. Gosh, I'm slightly lost, I guess. Go back to pictures. As I do. All right. So here's our dictionary. We're doing primaries only. I'm going to give you address of code. I guess we just want to run that address. Because if it gave us a secondary one, we would say the address of start2D. We don't care about X0 pointing into the block. I believe it's our duty to call this address. Yeah, I think so. Okay, so REPL. He calls dictionary search. We're going to assume he gets a positive result for now. And then he gets a pointer to the word address. I guess he's got to do a load address. X0 is contents of X0. Back to dictionary. The word address, which is the pointer to the contents. Okay, so we load that word address in here, and then we branch link register 0. Okay, so look up the dictionary word, assume it's found. It gives us a pointer to the address of a routine. Load that address, jump through it. Is it LDR? Yeah, you're right. Okay. Load X0 with the contents of whatever the dictionary finds. Branch through to it. Yeah, you're absolutely right. Load address is for labels, relocatable things. Okay, branch through it. Then you're back and you're done. I think you're basically done. Okay. It's weird because it's just like mechanism gets a bit in the way. If this were a secondary, we'd call start2D on it. We'd have to make sure X0 pointed to... Oh, it points to the word address, which is going to be right for secondaries. Okay, yeah, so I think this is it. Load the address, branch, BL's the call, subroutine call, but we're doing the addresses in a register. So, all right. All right. X0. Well, does it find it? Okay. All right. So I don't know. Is it worth debugging at this point, or can we? Let's test our way in here. That's that. I'm just going to load. X0 is this. L input buffer. No, that's not it. L test stack. Dictionary search. I want that push 42. Let's see, dict header. Yeah, I guess I can. This is kind of a temporary test. We'll just do it this way. I'll dict 1. dictator 1. It should be the address that we're after. Dictionary search on that. And then X1 gets, let's say 0, and then be able to assert equal. A little temporary subtest. L dictator 1 not found. Okay, so I don't know how to get to that. I thought it just started at 1. Maybe it starts at 0. I'll take that chance. They ripped. Thank you for subscribing. All right. Have you, I don't remember if you've been here before. Have you seen what we're up to? I don't want you to be too lost. Okay. So I'm just going to assume it's a 0 for now. And if it's not, we'll have to debug. I think we'll have to debug. All right. So at least we're debugging in the REPL. So I want to get here and decide if we can, if we're getting the right value back from the dictionary. It should point to the header for push 42, which should eventually point to the code for push 42. If X0 needs to have that when we get down there. Okay, so let's, well, haven't had to do any this week. Let's see. We'll do a make. And that's blowing up. Okay, so LLDB, REPL test.out. Over here, we'll dump this. Out. All right, and let's find our stuff. There's our data section. Okay. REPL test, push 1, push 42. That's just the string for it. I don't know what unwind info is. More test. That's from the, okay, I guess, break set, REPL. REPL test.out. Break set minus B REPL, no location pending. That's discouraging. Start, there's push 42. Well, you would think REPL would be right around here. Eval, dict search. Eval just push 1. Oh, eval. Thank you. Okay, and we'll run. Okay, so there's our store. Let's step over the store. Now we're branch link. That's our load address. Okay, so let's step over this one. Okay, and let's dump. Well, let's look at X0. Read X0. 4010. 4010 is push 1. Okay, we wanted it to be a string. Well, no, we called dict search though, or did we? Oh, wait a minute. Yes, I stepped over dictionary search. I don't think. No, something's wrong. 4010 is the text push one. Push one. What's that got to do with anything? I mean, unless I've just... No, that's push 42. Well, let's find X21. Because that's supposed to be our dictionary. Okay, system dictionary plus 24. Sorry, I'm not sure whether I've passed things or not. I really should do a clear. It helps a little bit. Okay, we gotta get back to the text section. We're looking for system dictionary. Well, okay, it's 4090. Plus 24. Well, that could be something, but everything else is 0. Have I forgotten some bit of setup? Okay, I mean, push 42, it should be... Well, this... Okay, I can believe there's like 3 sets of zeros, right? 3 words of zeros. Well, it's probably here. It's probably these 3 words of zeros. Then this is our pointer, which is empty anyway, so I'm not sure we needed that. Then the word push. Push 42. Well, no, it should be the address of push 42, right? Somebody should have a 4070. It doesn't look like 4070. Yeah, that's definitely not the right address to load, I don't think. It's a word. Well, an English word, kind of. That's what I'm wondering. Well, no, I think I'm not even convinced we have the right setup in the dictionary. Like, where the system dictionary, if it's 4090 plus 24. I mean, 4090. Well, there's nothing there, right? Now, these are 16s, right? So that should get us back to here, maybe. 4090 plus 24. So back there is 16, and then half of one of these is 8. So, I mean, I think it's saying the system dictionary is at this slot. So that was these 3 bytes of zeros, and then we should have added in these. I don't think our header looks good. Let's find dictionary test. Edit dictionary. Okay, we call a header. This is the best one to look at. Okay, we have dictionary header, and then we call load address this name. Dictionary search is returning. Yeah, let's make sure. I thought I did. Yeah, I called dictionary init. Dictionary header. Okay. And dictionary init. Well, it has space allocated, right? So there's system dictionary, theoretically global. I don't know why we didn't see it. Well, it doesn't do anything. It just loads these addresses in, which is fine. And then the dictionary macro kicks in and increases those addresses. So dictionary initializes x21, throws the name in a data segment. I had to push 42. Yeah, I mean, I don't know if did I mess up my string? I wanted to change it to push 42, but I don't know that I did anywhere. I'm missing one. Aha. Okay. I think we have a chance that it's me, not them, not the code. I guess that's an improvement. Okay. I'm glad we didn't spend long debugging, is all. All right, yeah, switching that name, that was it. Okay, and I should rename the procedure too, I guess. Push 42, let's push 42 on stack. All right, so this gets you So if you have one word and you pass it in, we process it. And then, all right. So I guess we want the case of if you come in with no word, I guess we want to bug out. I'm not sure that test case gives us anywhere to go. All right. So, well, certainly there's a test that goes for 2 words, right? Or multiple words. It's 84. Okay. So okay, I'm going to try some different approach. If I do this, no, I still don't get it. Okay. And I don't think I can tab blocks. Oh, it does. Oh, big stupid then. Okay. All right. So this time I want my input I want it to be more. But I think I can. I think I can do this. Sure to ASCII add. Okay. So we'll have to put add in there. Okay. And then maybe this is It's like, who controls the repeating? Is that us? Okay, so if you just execute one word, no, I think I want to make a separate case here. Test stack is fine. This, but I'm not sure we'll use this or not. Okay, this is L input 3 words. Add this to the test that needs it. Okay. And then use this there. Okay. Yeah, see, I'm trying to avoid the tokenizer yet. So I'm sort of saying, if you had PUSH420 0 byte, PUSH420 0 byte, add 0 byte, and then maybe a 0 byte after them, or maybe we track the length. Like, I almost want to make our eval loop. And if it goes in with a 0, it should stop. So we do need to test this 0 case first. Okay, so let's ignore that test case. We'll come back to it. Eval of empty string just stops. Now, print is not really, I mean, there's the dot word does printing, so it's not like Lisp REPLs, they print for you with the last evaluated expression, but we don't need to do that. The read will plug in later, and I think you're going to read and then do some eval print looping and then read again in that. So there's going to be an outer REPL that deals with getting the lines and all that stuff. Okay, so this, well, we're not going to call a dictionary, so I don't think we care. We probably have to initialize it, of course. All right, and then we load the test stack, yes, and the buffer. And I want the buffer to be, I don't know whether to put everything up here or not, but maybe I will. And maybe I'll spell it specifically. Okay. I'm not sure about locating things. L empty string. Okay. Now, okay, so if you start with an empty dictionary, you set up the test stack, you have an empty string, then this stuff's going to be kind of the same. Well, kind of. Eval of empty string. Okay, so I don't care about the value on the test stack because this should just be the test stack, empty test stack. Now, okay. So this has to be my termination. So I think I'm going to give you a pointer to something that has a series of strings ending with an empty string. In this case, we're testing the empty string first. Test that does nothing. All right, so I think all that happens is we're just going to assert that the stack pointer did not change, and we expect to come back here because if you didn't write, it wouldn't come back. Okay, so I think this is the test for that, and yeah, so that means we put in a loop, and this will be a guardrail when we do that. It should pass. Yeah, should pass. Okay. Yeah, because we didn't take care of it. Okay, so it's kind of a while loop, right? So if if x0 points to a string, okay, if x0 is empty, so maybe we'll do our x10 trick again. So let's store x10 at SP plus 8. Nope, that's not right. I think it goes inside, right? I gotta check off. Yeah, inside. Okay. Definitely can't be a post increment. And then at the end, we have to restore it. Is it like that? Golly. Inside again. Is that right? Oh, the XP. Oh. Sorry. XP. Okay, so it's SP plus 8, but this one then increments that back. Okay. Let's make sure this prologue is not breaking anything new. Okay. Right. So I want to move x10 equals x0 because I want to do a test on this string. Load x0 with contents of x0. I want to get the character. No, I got to do that differently. Where's our... See, like... I got to do a load byte thing, right? Yeah, that's what I want. Yep. Although I think x1, x0 is probably okay to use. We're going to re-initialize it. Over x1, x. Okay. So now I'm looking at that byte, and then is there a compare byte? Not compare branch. Oh. We must have done it in here somewhere. Oh, okay. Oh, you want to use W's. Yeah. Okay. I don't know if it really makes a difference. But I think this will do it. Okay, if that byte, load that byte, if it's 0, okay. Is that like what we did here? Load a byte, load the byte into the register. Why? Oh, and skip forward. We don't care about that. Compare it to a literal branch not equal outside. Okay, I think that'll. Okay, so I think this will. It'll save off x10, save off x0. We need the input. We'll look at this byte at where we passed in. If it's 0, then we're going to skip to the end. And then, yeah, and then restore for the search. Okay, so move x0 gets x10. Right. I just mean CMP. Okay. That feels like progress. So we don't force a loop, we just fall out the bottom. So this really does only execute 0 or 1. But, well, I guess it's basically time. We got 2 minutes. Let's fill in this test a slight bit and pick up here tomorrow. So I'm going to put this up here. Well, you know what? We're green. Let's at least check this in. Okay. So eval evaluates either 0 or 1 words. Okay. And then in here, the 3 words, did I put that in there? No. All right, so let me pull a little data area in. Oh, which I already did. Okay, input 3 words, eval. And this should be 84. And there should be 1 thing on the stack. Okay. This should fail. Hopefully it fails somewhat cleanly. Oh, darn it. Okay, it fails. We will pick up there. All right, so tomorrow we'll pick up there with evaluating a string with a bunch of words in it that's already been pre-tokenized if you want. And from there, yeah, so we'll push on from there, extending out the REPL. Maybe we'll write the routine that replaces the spaces with zeros or something. It'll need to be more sophisticated eventually. So we'll see how far we want to go. All right. Well, take care. I'll see you tomorrow, I hope, or some other time, 2 to 4:30 Eastern, 7 to 9:30 UTC. And I think daylight savings is coming for us next weekend, maybe, or something. It's coming soon. Not for us this week anyway. All right. Take care. Bye-bye.